Hey students, it's me, Mr. Fitz. This is going to be pretty long, this video, because we have a lot of DeltaMath problems to go through. So yeah, this is all about how we handle the compound interest questions in DeltaMath. So let's get right to it. Here's one example of a problem that you're going to see. Lucy invested $19,000 in an account paying an interest rate of 3% compounded annually, assuming no deposits or withdrawals are made. How much money to the nearest $100 would be in the account after 8 years? So remember, this is our compounding interest formula. The final amount is A, P is principal, R is interest rate, N is number of compounding periods, T is time. Now, if it's annual compounding, N is 1, so we can kind of ignore those ones, right? R divided by 1 is just R. T times 1 is just T. So let's go ahead and list everything. There's $19,000 is my principal amount. 3% or 0.03 is my interest rate. N equals 1. And T is 8. So let's just go ahead and set this up. So A is 19,000 times 1 plus 0.03 divided by 1 raised to the power of 1 times 8. So I'm just going to rewrite that as just 19,000 times 1.03 to the 8th power. So I'm going to show you how I can plug that into my calculator. So let's take a look at that. Okay, so Lucy invested 19,000. So I'm going to go ahead and say, what, 19,000? Here's my graphing calculator. 19,000 times, I'm going to talk kind of fast, so this video isn't like super crazy long. 103, you don't even really need to use the parentheses there. And I'm going to raise that to the power of how many years? 8 years. Okay. Enter. 24,068.63. And I need to round that to the nearest $100. So it's just going to be 24,100. So let's go back. See, make sure I wrote that down correctly. 24,068.63. Note, if you were trying to find the interest amount, you could subtract the principal amount. Remember, this is the total amount that we have to owe, principal and interest. If I subtract out that principal amount, the amount of interest I earned is just 5,008.63. So that's kind of useful information, right? It's a pretty decent amount of interest. So to the nearest $100, that would be just 24,100. Okay, let's look at the next one. So this one is a little different. Austin invested $60,000 in an account paying an interest rate of 4.7% compounded quarterly, assuming no deposits or withdrawals, of course. How much would Austin have to the nearest $100 after 11 years? So again, here's our formula. The principal amount is 60,000. That's the starting amount. Interest rate is 4.7%, 0.047. Compounding in this case would be 4 because it's quarterly. There are 4 quarters in a year. So it's like paying every 3 months. 4 quarters, 3 months, 4 times 3 is 12. And then it's for 11 years. So it's going to be N is 4, T is 11. Okay. Let's go ahead and calculate that. So A is 60,000. 1 plus 247 divided by 4, and I'm going to raise that to the power of 4 times 11. So 4.7 divided by 4, 0.047 divided by 4 is 0.01175. Check that in your calculator. So it's going to be 60,000 times 1.01175 to the 44th power. And what I would get is 100,316.56. The little squiggly equals means approximately. So that's approximately equal to that. Let's try that in our calculator as well. Let's take a look. Okay, so what would it be? It would be 60,000 times, in parentheses, 1 plus, and I'm going to put this in parentheses as well, 0.047. If you want to do this as separate calculations, please do. Divided by 4, close the 2 parentheses because I have 2 open parentheses there, right? Open, open, close, close. Raise that to the power of 4 times 11 or 44. and I get 100,316. So to the nearest 100, that would be 100,300. Yes. All right. Next one. Mila is going to invest in an account paying an interest rate of 2.5% compounded annually. How much would Mila need to invest to the nearest cent for the value of the account to reach $44,000 in 14 years? So this is kind of flipped on its head, right? They're giving us the final amount and the interest rate. They want us to know how much we need to invest. So I know my final amount is 44,000. I'm looking for the principal amount in this case. So I know my interest rate is 2.5%. Again, it's annual, and T is 14 for 14 years. Remember, these interest rates are annual interest rates. So 44,000 equals P times 1.025 divided by 1 to the 1 times 14th power. So again, probably get really good at writing these down after a lot of practice. 44,000 equals P times 1.025 to the 14th power. Multiplication happening here, right? The inverse operation of multiplication, division. So I want to get P by itself. So I divide both sides by 1.025 to the 14th power. What am I left with? Well, 44,000 divided by 1.025 to the 14th power. That's what P equals. So let's take a look at that in our calculators. Okay, so it is 44,000 divided by 1 point, what was the interest rate? 2.025, right? 2.5. 1.025 and to the 14th power. Notice I didn't put that in parentheses. That's okay, because this whole number is being raised to the 14th power. You don't have to use parentheses right there. And I get 31,139. Let's see if I got that right on here. 31,140. Oh, what did I do? Let's take a look. Oh, I need to round this to the nearest cent. So if I hit math, scroll over, round, second answer, and to the nearest cent, that would be 2 decimal places, right? Oh yeah, 31,140. Oh, that makes sense, right? Because it's 0.996. So nearest cent, everything gets rounded up. Nice. Okay, next problem. 31,140. Dominic is going to invest $1,800 and leave it in an account for 17 years, assuming the interest is compounded annually. Again, what interest rate? All right, so we're trying to solve for the interest rate to the nearest tenth of a percent would be required in order for Dominic to end up with 4,700. Okay, so now let's see. I'm trying to find interest rate here. So I know my amount is 4,700, and I know that's my ending amount, right? And I know my principal balance is 1,800. I'm looking for my interest rate. N is 1 and T is 17. So 4,700 equals 1,800 times 1 plus R over 1 to the 1 times 17th power. So in this case, it'd be 47 equals 1,800 times 1 plus R to the 17th power. Again, this is multiplication. So I divide sides by 1,800. This leaves me with 4,700 divided by 1,800 equals 1 plus R to the 17th power. Now, if you remember your power rules, if I want to get rid of this exponent, I can raise this whole thing to the 1 over 17th power, because a power to a power, you multiply them. So 17 times 1 over 17 is 1. If I do that to both sides, I'm good. So what does that leave me with? 4,700 over 1,800 to the 1 over 17th power equals 1 plus R. But remember, I want R by itself. So I need to subtract 1 from both sides. So that leaves me with R equals this whole thing and that ends up being 0.058 or 5.8%. Let's look at that in our calculators. Okay. What do I need? What was the amount? Okay, so my ending amount is 4,700 divided by my initial amount. Oh, I should have put that in parentheses. That's okay. I'm just going to take it in steps this time. So what does that leave me with? 4,700 divided by 1,800 is 2.611111. I need to raise that to the 1/17th power. So I'm just going to hit this. And I'm going to put that to the power of 1 divided by 17. What does that give me? 1.058. Oh, right. I have to subtract 1, right? So remember, I have to subtract the 1. So if I subtract 1, and I can multiply that by 100, so that gives me an interest rate. So it's 5.80815 whatever percent, and I need that to the nearest tenth. So I could do round, or actually, the nearest tenth is 5.8, right? Because that's a 0. All right, so it's 5.8. Excellent. That's what I got, 5.8. All right, next problem. We're flying. Good thing it's a video, you can always pause. Matthew invested 5,300 in an account paying an interest rate of 2.1% compounded annually, assuming no deposits, blah, blah, blah. To take the, how long would it take to the nearest year for the account to reach 6,020? All right, so again, here's our formula. My final amount is 6,020. My initial amount is 5,300. My interest rate is 2.1%. So if n is 1, what is t? All right, let's see if we can find that. So let's take a look. So 6,020 equals 5,300 times 1.021 to the t. Right, so I just kind of simplified this automatically because I knew this is annual. These, I don't have to worry about this. It's just 5,300 times 1.021 to the t power. This is, again, multiplication. So I need to divide both sides by 5,300 because I want to get t by itself. So what do I end up with? Is 6,020 divided by 5,300 equals 1.021 to the power of t. Now, for those of you that remember this from Algebra 2, if you have a variable in your exponent, what do you have to do? You have to actually use logarithms. You have to take the log of both sides, and then you can use your logarithm rules to simplify the problem. So let's take a look. If I take the log of both sides, and I used log base 10, you could use natural log, which is log base e, as long as you're consistent as to which base you use on both sides. So if I take the log of both sides, then what I can do is I can move this t with my logarithm rules. I can put the t up front. So this log of 6,020 divided by 5,300 equals t times the log of 1.021. Now this is multiplication. I can divide both sides by this log of 1.021, which gives me t equals log of 6,020 divided by 5,300 divided by log 1.021. Let's take a look at that in our calculator. Okay, so here's my calculator. So if it was log, again, you could use natural log if you want, just make sure you're consistent. Log of 6,020 divided by 5,300. Close my parentheses. And then I can divide that whole thing by the log of 1. Whoops, I forgot to hit log. Log of 1.021. Close my parentheses, enter. And you get 6.123. I want to round that to the nearest integer. Which would be 0 decimal places. And you get 6. So 6 years. Great. All right. So one thing I also wanted to show you is because we use the same equation the whole time and just kind of manipulated it using algebra, I also recreated like all of these, the equation for all the different types of problems. So for example, 6 years, right? If you're just looking for the final amount, right? If you're looking for A, you can just use this equation here, right? Principal amount times 1 plus the interest rate divided by the number of compounding periods raised to the power of the compounding periods times time. If I'm looking for the principal amount, I just divide both sides by this whole thing, which is just going to be the final amount divided by 1 plus r over n to the nt power. If I'm looking for the interest rate, so if I'm looking for the interest rate, and I want to, I'm assuming this is annual compounding now to make it a little easier, so I got rid of these n's. So the interest rate, if it's annual compounding, which all the DeltaMath problems are, it would be the final amount divided by the initial amount and raise that to the 1 over t power and then subtract 1. So that's if you're solving for the interest rate. Lastly, if you're looking for time, if the problem is asking you for the amount of years, so it would be the log of the final amount divided by the initial amount, all of that divided by the log of 1 plus the interest rate. So you might want to write these down. Hopefully this helps. I'll make sure to try and put these in the video notes as well. And please, please, please let me know if you have any questions with these DeltaMath problems. And again, thank you so much for watching. Hopefully this wasn't too long.